So in section 1, we learned about the multiplicative or multiplication properties of exponents. Sorry about that. In section 2 here, we'll learn about the division properties of exponents. So we'll just kick off with the rule, which if you remember, when we were multiplying two bases, or multiplying two powers that have the same base, we added the exponents together. So hopefully it makes sense then that with the quotient of powers, if we divide two powers that have the same base, we will subtract the exponents. So multiply, you add, division, you subtract. So for this one, we just simply look and say there's a 4 on top, a 2 on the bottom. So this becomes x to the second, or x squared, because 4 minus 2 is 2. And number 2, a is our base. 10 minus 4 is 6. Okay, number 3. You can also get negatives as your answer. The base is m. 3 minus 7 is negative 4. Now there is another way you could write this, but for now we'll just stick with the negative exponents. Number 4, x is our base. 4 minus 10 is negative 6. Okay, now on 6, just like we talked about in the last lesson, you got to think of the coefficients as their own separate thing. We're not going to subtract 6 minus 2, because 6 and 2 are not exponents. They're coefficients, so we just follow normal rules with them. We just say 6 divided by 2 is 3, but since these are exponents, we have an x to the third and an x to the first. 3 minus 1 is 2, so this simplifies to 3x squared. Number 6, we have two different variables, two different bases. So g cubed over g to the first. 3 minus 1 is 2, so it's g squared. And 5 minus 2 is 3, so it's h cubed. Now, if you're dividing multiple powers, you notice on this one, we ended up with positives both times, because in both of these, both g and h, the exponent was bigger on top than it was on the bottom. However, when it's bigger on the bottom, we want to keep the term where the exponent is biggest and subtract. So let me show you what I mean. There's two ways we can approach number 7. One is to say that for a, we do 4 minus 2, which is 2. For b, we have 1 minus 6, which is negative 5. Now, mathematically, this answer is completely correct. But what our book prefers us to do when we've got multiple variables is keep all the exponents positive, meaning since I have a to the positive 2, I leave that on top of the fraction. And since I have b to the negative 5, I should move it to the bottom of the fraction and make it a positive. So remember, a negative exponent can be changed to be positive if it switches, whether it's in the top or the bottom of the fraction. So you can take it in 2 steps this way, and that's completely fine. Another way you could approach it, you could say, okay, I'm looking first just at the a's. Where's the exponent of a bigger? Well, clearly that's on top. So I'll do 4 minus 2 and get 2. Now with the b's, I'm bigger on the bottom. So since it's bigger on the bottom, I know b needs to stay on the bottom. So I do 6 minus 1 and put the 5 on the bottom. Now, if this way makes more sense to you, go for it. Take 2 steps. But if it's clear to you that we just do the bigger one and we subtract from that, leave it on whatever side of the fraction it's on, you can go straight from here to here. Okay, now number 8. X to the 5th over x to the 5th. Well, anytime you divide something by itself, the answer is just 1. Or, if you think about it, we do 5 minus 5, which is 0. And as we learned in the previous lesson, anything to the 0 power is equal to 1. So essentially, these just cancel each other out because they have the same exponent. But the y's, we have a 3 on top and a 1 on the bottom. The 3 is bigger, so y will stay on top. And 3 minus 1 is 2. Number 9, we look at a squared and a to the 5th. The 5 is bigger, so I'm going to treat this as a line for a fraction. The 5 is bigger, so we're going to keep a on the bottom, and 5 minus 2 is 3. Now with b, the exponent in the numerator at the top of the fraction is bigger, so I just keep b on top. 7 minus 2 is 5. So we get b to the 5th over a cubed. This is a fraction. B to the 5th over a cubed. Okay. Now, this is very similar to what we looked at the back of section 1, but it does work also with quotients. So when you have a fraction that as a whole is raised to an exponent, like you see here, this whole fraction is being squared. This whole fraction is being squared. You need to raise the exponent, you need to apply the exponent to both the numerator, the top, and the denominator. Now we're following the same rules as we did with the power of a power, or exponent of an exponent, which we talked about back in section 1, where we multiply. So 2 times 2 is 4, so that stays on top. 2 times 3 is 6, that stays on the bottom. And now that we've applied that part of the rule, we can apply the rule we learned today, where we look and see, okay, if I'm dividing the same base, I subtract the exponents. 4 minus 6 is negative 2. Or that can also be written as 1 over x squared. Those are both the same. Okay, number 2 in this category. I have to square everything I see here. 4 squared is 16. A to the 1st squared, I do 1 times 2, so a squared. 5 squared is 25. B squared squared, we do 2 times 2 and get 4. So we've applied that squared to every piece of each term in this fraction. Number 3, remember when you square a negative number, negative 3 times negative 3 is positive 9. M to the 1st squared, we do 1 times 2 and get m squared. 2 squared is 4. N cubed squared, we do 3 times 2 and get n to the 6th. So I keep emphasizing this because as I've taught this, I've seen mistakes over this over and over and over. Treat coefficients like normal. Don't try to apply the exponent rules to coefficients. Only apply exponent rules to exponents. So always treat coefficients like normal. There's nothing that's changed about coefficients. Always follow the rules.